So we at GloBIAS, we want to focus on knowledge exchange. We want to, for example, develop a curriculum for bioimage analysis, and we want to maintain repositories with training materials to make training knowledge exchange easier for the next generations working in this field. So also standards and events. Obviously, today is an event. We are working on bringing people together to exchange knowledge. We are very glad that this project is funded by the John Zuckerberg Initiative and hosted by German Bioimaging. So as part of the efforts, we have our seminar series. So that's why you are here today. Again, this is for bringing people together. Here in this particular case, we want to thank the Broad Institute that we can use their Zoom accounts, and that Beth in particular and Esteban are helping us with like setting up these meetings and running and organizing all these things. And last but not least, before I introduce our speaker today, you see already here that the next meetings are already planned. There's a new topic now for the next 3 webinars, will be about infrastructure for deploying image analysis workflows. I would like to introduce the speaker of our webinar today. It's Loïc Royer, a world citizen, I would say. So born in Paris, lived for some time in Berlin and in Dresden, did his PhD in Dresden. I think at the time when I did my PhD in Dresden, and Loïc, we never met there at this time. So Loïc moved on to Genelia to join Gene Meyer's lab. And this is actually a fun story. So he joined Genelia, moving to the US, and half a year later, correct me if I'm wrong, Loïc, Gene decided to move to Dresden and move his lab there. So Loïc came back and stayed for another 5-6 years. And then eventually I was able to work together with him. And it was a very inspiring time until Loïc decided to move to San Francisco, become group leader at the John Zuckerberg Biohub. And today, I had to read it again, you are now Director for Imaging Artificial Intelligence, Loïc, right? So with that, I will stop talking. The stage is yours, Loïc, and we are very happy that you are here with us today.
Yeah, thanks a lot, Robert, for the kind introduction, and hi everyone. Hi everyone. Thanks to all the organizers for this. This is a great opportunity for me to present what's really a weekend project. It started as a weekend project, and I have to clarify something, because I think I had a on the meaning on the meaning of weekend projects, because I got a comment on that. What it means for me to do a weekend project is that it's really something that I feel that there's such an urge to do, because I think it's something very exciting that I would start it on the weekend. And so what happened is that sometime last year, ChatGPT came on the scene, and I was very excited with this, like everybody, frankly, with this incredible, technology that just landed like an alien on our, global consciousness, right? And so, and kind of, I started thinking about how to use that. And so really, what happened is I started working on this on the weekend, and then the rest is a story I will tell you now. So basically, but just before jumping into that, maybe I just quickly introduce my team and what we do very quickly, just to give you a sense of where I come from, why I needed to build this thing, why I felt like that this was a useful thing. So I work at the John Zuckerberg Biohub, as Robert explained. We are kind of a non-profit private research institute in the Bay Area in San Francisco. We bring together the 3 universities there, Berkeley, UCSF, and Stanford. And really what my team is trying to do is build instruments, write software to control the instruments, but also to analyze the images coming out of the instruments. And we take all these technologies as a whole and try to answer questions about how embryos develop. And we use zebrafish as a model organism. So that means that we have to build these instruments, we have to produce these data sets, we have to do segmentation and tracking, and then we also have been dabbling into other modalities, such as single cell RNA sequencing. So of course images are super central to everything we do. And so therefore, we've been, working on a lot of technologies. And recently, really what I was excited to do is to work on this, the nexus between these new LLM technologies, in particular, ChatGPT and the sort of kind of frontier models, and bioimage analysis and processing and analysis of images in biomedical field. So, but really, the real starting point of this project was essentially, oh, sorry, I need to get my mouse back, but it's gone. Okay. Sorry, I'm trying to understand why I cannot access my mouse. Because I have like part of my screen obscured here, which is extremely annoying. Okay, whatever. So yeah, the real starting point was basically Rita Strack, who asked me to write a piece for Nature Methods on the future of bioimage analysis, and this was really right at the time where ChatGPT came about, and so in addition to some thoughts about what the instruments of the future would look like and what would that mean for bioimage analysis, I also very quickly, the piece quickly delves into this idea that perhaps, bioimage analysis in the future could be a dialogue between mind and machine. And so really what I had in mind was something where you would basically spend an afternoon, perhaps in the best case scenario, having a dialogue with the machine. You present your data, you'd explain what you want to do with it. The machine would propose solutions. You would, give some feedback. It would start writing code, running algorithms on your data. And this could be not just imaging data. This could be any kind of data, frankly. But for my particular purpose, I was thinking about images. But of course, you want to also turn images into knowledge. So sometimes an image starts as an array of pixel or voxels, and it becomes maybe a table. Maybe you have to extract some statistics from the table. But long story short, you would have this dialogue, and you would build pipelines and then build analysis, and then at the end of it, you would have essentially perhaps solved your processing or analysis task on these data sets in an afternoon, instead of maybe having someone work for 3 years, the 3-year PhD trying to solve that problem, which is oftentimes for truly challenging problems. It's oftentimes a multi-year task to solve these complicated processing and analysis tasks that we have to do on images. So that was kind of the vision. That was kind of a 10-year vision type of thing. And I realized, of course, seeing everything, all the things that people were doing on the internet with the ChatGPT API, I realized, wait a second, actually, perhaps this long-term vision is difficult to achieve, right away, but we can maybe get pretty close to something already pretty impressive with the existing technology, because these models are so incredible, and they were at the time not as good as they are today, but they were good enough to do some pretty cool stuff. So really, like within the span of a month or so, at some point I decided to, I needed to write some code to really test these ideas. And the first thing I did is just try on ChatGPT on the web, in the browser. I just was testing things, and this kind of started on the weekend, but it was not just a weekend. Of course, I ended up spending a lot of time doing that. I was I went for 2 weeks to see my parents in Paris, and because some health issues, and I basically ended up coding for 2 weeks straight. No meetings, a lot of deep work time, and so I ended up writing Omega, which is this ChatGPT-based napari conversational agent specialized in image processing and analysis. So, I mean, at this point, I don't think I need to introduce napari, which is this kind of n-dimensional image viewer in Python, that we started with Juan Núñez Iglesias, Nick Sofronev and others here in San Francisco originally, and which has now, taken a life of its own with a very, a thriving community of open source developers. So yeah, so I basically decided to combine these two very interesting technologies, napari and ChatGPT, and see what I could do with it. So here's the result. So basically, you can open napari and then start the plugin Omega essentially, and then when you start the plugin, you have a browser window that opens. And you can basically start a dialogue with the machine. So you can start, chatting, like any of these chatbots that you've been using for the past year and a half or so. You can start, talking to Omega and asking Omega to do things with the napari viewer. So you can, for example, here, change the way the image data is being viewed. You can switch from 2D to 3D viewing. You can rotate the viewer, camera to be able to look at the data from another angle. You can zoom in, and every time you ask something from Omega, what happens behind the scene is that there's code written. And there's a lot of things happening to making sure the code actually runs correctly. If it fails to run the first time, it just looks at the exceptions and tries to run it again. So there's lots of technology which I'll explain towards the end of the presentation of how I made sure that this actually works with higher frequencies than would otherwise. And so you can continue interacting with the viewer and do things. And one thing you can do is, of course, for example, ask to open an image. So here we asked Omega to open a ZAR file, and I just took one of these nice exemplary data sets from the I believe this is the IDR, yes. So these are data sets that are stored at the IDR at EBI, and so this is a 3D stack. I believe this is an organoid. I'm not sure. I don't remember which data set that is, but I believe this is an organoid, or something like that. I'm sorry, I don't really remember what the data set is. But for our purpose, it's just a ZAR file, probably a OME ZAR file. It's opened in napari, and I just had to ask for it from Omega, and so you can basically also open files that are locally on your computer. It just understands what you want. It just works. Yeah, and then we can also ask things that are a little bit more I mean, that so one thing that happens with Omega is Omega has access to a lot of tools that give it access to actually the internet. So it has actually access to internet. It has actually, it can actually do web searches, and including downloading images that are with the result of finding them on the web. In general, it also can surf the web, and it can essentially answer questions on the basis you can provide a website, and then it will will look at it, and you can ask for essentially, you can do Google and Wikipedia searches to help answer questions you might have, or solve tasks that you're asking for. So another one thing that I wanted to really to demonstrate with Omega was how you can actually tightly integrated with some very popular tools like Cellpose and StarDist, for example, here in the case of cell segmentation. And so here's one of my favorite examples where I asked to segment the nuclei present in the selected layer. So Omega has a notion of what are it knows which layers are present in the viewer. It knows which ones are selected. It knows a lot of it has information about the resolution of the images, about the type, and so on and so forth. And here it writes code that essentially invokes, the StarDist segmentation routine, and it just segments the image. So that works great. Then we can ask for, follow-up analysis, which would be here, count the number of segmented cell nuclei. And it basically, starts writing code for that, a very simple piece of code that will count the number of segments in the labels layer that was produced by the previous, interaction. And it returns, okay, there's 317 segments. That's great. The next thing we can do is we can ask Omega to write a CSV file on the desktop that lists all segmented nuclei together with the area, coordinates, sort the rows by decreasing area, open the file when done. The first time I tried this, I was like, okay, just let's see what happens. And it happens. So it writes code that essentially does everything we've described, this old Python code, and including code that knows how to open, the file on the system here, this command os.system open, So it really it knows, it knows how to write Python code, and when you know how to write Python code, you can do almost anything on the machine, including, asking for files to be that have been written to the desktop to be open on the desktop. So that was kind of, a bit of a goosebump moment, right? Imagine this was happening. I don't remember exactly when I started working on Omega. It must have been like sometime, yeah, it was like early spring or late winter. I don't remember exactly the months, but it was pretty early on in the kind of, LLM craze, and I was a little bit shocked by, but with what was possible, right? Frankly. So something that I think is probably one of the most interesting things that you can do with Omega, or better said, maybe one of the most practical things that I find very, very useful, is to basically make widgets. And I think of widgets as generated by Omega as kind of micro plugins or nano plugins, which is like, create kind of asking Omega to add small interface elements, some small UI elements to napari very quickly, on demand, and exactly the UI element you need. So you can generate, hyper specialized, on demand, on the spot, small processing analysis tools that are just doing the thing you need to do right there, right then. So here, for example, I asked for a widget that can filter labels in the labels layer based on the surface area of the segments. So you basically end up with a widget that has a mean and a max, and essentially anything that's outside of that range gets filtered out, and it just works. So I ask for it. It makes it's added automatically to the UI of napari, and and so this is, you could write a plugin for it. That would be an extremely, heavy operation to write a plugin just for something that does that. Instead, you just, you just need Omega, and then Omega can make that kind of micro planning for you. And that's actually why Omega is called Omega, because it's the last letter of the Greek alphabet, and the idea that's the last plugin. It's the plugin next to other plugins. Of course, that's not the case. That's not how the world works. I don't think Omega can make all possible, plugins in the future. I mean, maybe in 10, 20 years, maybe something like that, something like Omega could really, like, make anything you want, even things that are, maybe the result of truly a 3-year PhD in bioimage analysis and processing in just, in just 3 minutes. But that's not currently the case. But that's kind of the reason why I called Omega. Omega is this kind of ability to generate kind of micro plugins, if you want, instantly. So probably one of my favorite plugins, because actually I've been using it a lot, is a plugin that creates that does 3D color projection in the napari. So please write a widget that color projects a 3D stack along the z-axis. The hue of the projected pixel is proportional to the depth of the voxel of max intensity. The luminance is proportional to the max intensity, and the saturation is proportional to the contrast between the max intensity and the average intensity along that projection axis. So essentially, with the three dimensions of that of color space, which in HSL basis is hue, saturation, luminance, you can encode as much information as possible about the column of voxels that you're projecting. It writes beautiful code, commented, working code, and it adds it to the interface. You can run it on your image, and look, it's beautiful. You can nicely see the little chromosomes here in different colors because they're in different heights within the stack. What's the saturation thing here? What it does is basically it removes color from places where there's no well-defined maximum within the stack, right? So that's the little tricky thing there, little trick here, it just that little thing adds a little kind of twist to the color projection that in this case, Omega on the first time I tried it, just did it perfectly, completely understood what I meant by with this this kind of contrast between max and average along the column, and it basically what it does is it prevents the noisy regions or the kind of empty regions to have kind of color noise, because essentially there's no point in having colors here because there's no when there's in the empty parts of the stack, there's no point to have really any information about depth. So that's great, and you can at this point anything is possible, and I've tried so many different widgets for so many different purposes. You can create a widget that crops images in a special way with the right exact parameters you need to have. You can create a widget that takes two images and combines them in some weird way that you just need between 4 p.m. and 4:15 p.m. or something in one day, right? That you can just create this kind of on-demand tools that are exactly what you need, exactly when you need it. And it's only limited by your imagination. So this is, like, I think you've heard recently, how some of the recent frontier models, especially ChatGPT 01 preview and mini, have incorporated some notions of reasoning. And this is not something entirely new. It's just that these models have been now optimized and kind of fine-tuned to think very carefully and very and in a very strategic manner. But you could already, from the very beginning, you could already nudge LLMs into thinking in very organized, strategic manner. So here, in this video, what we do is we say, okay, here's an image, and I needed Omega to make a step-by-step plan to segment the nuclei in the 2D image. And it understands that a 2D image is could be the selected image. But here the point is not to do anything, it's just to think about what to do, right? And I gave a little bit of information about the image. I said the nuclei brighter than the background. So it comes up with a plan. The plan involves loading an image, applying a Gaussian filter to smooth the image, threshold the image to create a binary image, and where the nuclei are set to 1 and the background is set to 0, perform morphological operations, for example, opening to remove small artifacts and separate touching nuclei, label the connected components in the binary image to assign a unique ID, and so on and so forth. So it goes through kind of a standard, segmentation plan. And of course, it also suggests, look, I have special means of segmenting images. I have special tools at my disposal. I can use, you can use Cellpose, for example, or StarDist. But here, what I said, okay, no, let's just apply the first, the third step, because the image is already loaded. It doesn't look like it's a very noisy image, so we don't need to blur the image. And here, this is really a collaboration, right? You know some things, so there's no point in in doing things that are not unnecessary, right? So here you say step 3, it remembers what step 3 is about, it writes a code for it, applies it, and now you have a new layer on the napari viewer, and on the list here, you have a new layer, which is this binarized image. It used Otsu, solid and safe bet, and that's great. And then after that, oh, sorry, I think I went a little fast here. Yeah, so then I asked for, so I know, yeah, and then asked for step 4, is just to do 2 erosions. Because maybe this kind of segmented nuclei, they're a little bit close to each other. So I asked for that, and it's basically thinking a little bit, writing some code, and okay, the nuclei have been eroded. That's great, and this is now a new 3rd layer that's been added. We can compare. Yeah, that looks good. And then the next step, right, is actually to question a little bit here. Would it not be better to apply erosion or opening first on the gray level image instead, right? So we kind of so this is also a way for people to learn image processing, image analysis, because you can ask for you can argue a little bit with the thing and ask questions, and here basically we have a new plan that, so maybe I came up with a new plan, and then we can maybe I removed the layers that were added, and now we do the step 3 again. Okay, the step 3 now is to do a gray level, to use gray level morphology, right? Directly on the original image. So to avoid kind of the loss of information that the thresholding causes, and therefore I have maybe a better chance to separate that better, right? And then that also helps with the small artifacts and so on and so forth. I'm not pretending this is the absolute best way to segment these images. This is more, don't criticize me, please, on my basic image processing skills here. This is really for demonstration purposes of what Omega can do on some very simple image and with very simple tasks. So so then we can continue and do some kind of more manual kind of exploration and experimentation of different things, like here I'm playing a little bit with different steps of erosion and so on. And at some point you're happy, and then at this point if you don't know if you don't know what some of these operations in this in this plan mean, you can simply ask Omega, okay, can you explain to me what is Otsu thresholding, or what is gray level morphology, or whatever, and it it will explain to you, like it's behind this is ChatGPT, so it knows everything that ChatGPT knows. So you can do that, and then so now we went through the last step, which is to turn that into a labels layer, where you have this difference. You have the segmentation with different segments identified with different IDs per segment here in this labels layer. So that's great. So that's an example of this kind of dialogue with the machine, right? And of course this is extremely simple. I don't I'm not gonna pretend that this works with super complicated tasks. Of course, I mean, I don't think ChatGPT is as smart as the best bioimage analysts out there, right? I mean, it's getting better and better every day, every week, every month, and so I think in a few years we might have genius level LLMs, and they're already like genius in some ways, but they're not there yet where you can really like just give your PhD project and the thing comes back with something ready in half a day, right? So we're not there yet. So one important way, an important thing about Omega is so there was a lot of technology I had to develop, or I mean, technology is a big word, but a lot of code I had to write to maximize the chances that things would go well. And one important aspect is the recovery from failure and mistakes, errors, exceptions. Any, Omega needs to be able to react to code that is written but that is not running correctly, or like just crashes. So, these LLMs, like people, they make mistakes sometimes when they write code, or sometimes it's just not their fault, as it's not our fault always. Like, for example, if you write code and you think a library has a function that has a certain signature, and you think there's a certain parameter you have to provide in a certain way, but the version of the library has changed, your code might not run, although it was running like the day before or something. It's the same situation here. What I do in Omega to minimize the chance that things go wrong is I actually inform Omega up front about the versions of all the bioimage and data-related libraries present on the system. So it knows about, and I know for a fact that ChatGPT and the frontier models in general, they know about all these different versions and about all the changes between the versions of all software. So informing the LLM about the version of the libraries is a good way to prevent a fraction of issues. So here's an example. So I asked from Omega to segment this RGB image using the rather popular sleek super pixel segmentation algorithm. That was kind of at the time where it came out, was a very popular super pixel approach for natural RGB images. It's kind of thinking a little bit about how to do it. It's writing code for it. This is a video I made with the old version of Omega, so there's no code coloring on the chat window. And you see there's an error, so it fails. There's an unexpected keyword argument that was provided to Slick. So I think if you look at the code here, I think it's the multi-channel argument. The multi-channel argument is not recognized. So this is a scikit-image version mismatch here. Despite my best efforts, it just picked the wrong, it wrote against the wrong version of the library. And Omega tries to run the code, it fails, it knows about it, and what it does now is, because it's an agent, Omega is designed as an agent, it can further think about the next steps that it needs to do. So here, what it realizes, okay, so there's an error. The error is that the multi-channel parameter is not recognized. So now I'm gonna try again and write code that doesn't have that call, right? So let me see if I can go back a little bit in the video. But so it realized, okay, the multi-channel parameter was removed from the scikit-image sleep function call as it was causing an error, a type error, and then it writes this new code where there's no multi-channel parameter called, and it works, right? So that's great. This was already possible with the very, very first version of Omega. Since then, I've added a lot of additional kind of safety features, or like code repair features that basically, for example, right now, internally, it will try to run the code multiple times until it runs. Every time there's an exception or an error, it gets that error and then tries again and tries again. So there's a lot of internal rumination that is now not even visible to the user. It just it's like an assistant that goes in the next room and tries to solve the problem, doesn't communicate to the boss all the all the issues that have been going on along. So that's a little bit but still, if eventually it fails, then the error gets propagated at a different level of reasoning and introspection. So this is another example. Oops, that's not how it should look like. Okay, what's happening? Okay, so, oh, this is not activated. So, okay, so I don't know why I'm, oh, okay, no, that's, oh, that's correct. Okay, that's fine. Okay, so, yeah, there's a, I'll see if I can, no, okay, I will probably not be able to recover from that. So here, there's a part of this video that just somehow is missing, but I asked for a widget that makes a scale bar. It's very cool. So you basically ask for a scale bar and it creates a scale bar. And what happened is the first version of the scale bar was broken because it didn't realize that if you draw a scale bar with intensity 1 on an image that has intensities up to 255, that scale bar is going to be very, very difficult to see. You see here the scale bar is black on black, so here you cannot see anything. And so basically I say, look, modify the widget, make a new widget with the same features, but add a parameter for the intensity of the scale bar. So you see the original widget was, you could define it with the length in microns and the pixel resolution in I think it was like what was that, micron per pixel or something. And then based on my feedback, it creates a new widget that has the intensity of the scale bar. So now I can actually make a scale bar that's actually visible, right? So that's an example of how you can also recover from errors through the dialogue. And because there's this awareness of what has happened before, and you can basically really have an actual conversation instead of just constantly asking for the same thing again and again until you get it. So that's an important feature, I think. More recently, I think, more recently, it's probably like already like probably more than a half a year ago, I added the ability for Omega to see. So what that means is now, these foundational models, these frontier models, like ChatGPT, Claude, and others, they are multimodal now, so they can also ingest images. So here I basically have a little puzzle. So which of the 4 images depicts a cup of coffee? So there's 4 images loaded in napari. The names of the layers does not give away like the content of the image. And I basically and then basically Omega starts looking at the whole canvas here. It identifies that there's four images. It describes them as well as it can, and then on the basis of this information, decides that the cup of copy is the one on the top right corner of the composite image here, right? That's not exactly what I wanted as an answer. What I wanted to know is what's the name of the layer, right? That's the actual answer I want. And so what it does now is it actually guessed that because of the layout, it should be B, and then basically essentially looks at the layer B specifically, double checks that it's actually a cup of a cup of coffee, right? And then so really like, and now it's really sure that this, okay, so it gets B, double says that B is really a cup of coffee, and then give me an answer. The layer corresponding to the image that depicts a cup of coffee is named B. And yeah, that's kind of cool. So it can, so now with this multimodality, now Omega can see, and I don't think it sees as well as humans yet, but it's already pretty impressive. And for example, what you can do with it, and actually, this is something that Robert, I think Robert, I think you suggested something on Twitter. I kind of I showed this video, the first one, and then I think you mentioned that one could do something like this, which is essentially ask, if I go back to the beginning of the beginning of the video, is I can load 2 images, right? you know, as an image with nuclei, an image with cytoplasm, and we can ask to segment the biological structures on the two loaded image layers. For each image, please look at the contents and to determine what these structures are and how to segment each one of them best, right? So it does a lot. Then what happens when you start this, you know, it does a lot of things, and it goes a little quickly here, so I'll try to. So what happens is that it looks at both layers, both images, describes both images on the basis of these two descriptions, and this is all kind of internal planning that's happening. It then decides, okay, I should use Cellpose for I should use Cellpose for the image where you have cells, you know, and cytoplasm, and I should use, you know, StarDist, of course, for the nuclei. So it's kind of, you know, and the reason in this order, because, you know, StarDist is specialized for nuclei, so it's kind of better to do it this way. If you, I don't know if I can show the beginnings before it went a little bit quickly. Yeah, here, if, oh, God, I have access to, trying to get access to this, there's no video slider here. I wanted to show you guys like the description of both images. What's interesting about it is it has trouble. It has trouble, you know, understanding exactly what these things are, but it comes close enough in describing these. You know, for example, here, like it says, the overall impression is one of randomness and dispersion, reminiscent of celestial bodies or microorganisms observed in a scientific context. So the description of both images is not perfect by any means, but it's enough information to be able to best match the description of Cellpose, because I have internally a description of Cellpose and StarDist, to do the best match possible between this, right? So it's kind of cool. And so it basically, you know, looks at both images and then runs both algorithms, and that is just fully autonomous. So looking at both images and then running the two algorithms is done without interaction. And then at the end of it, it just summarizes, okay, the segmentation biological structure on the two loaded image layers has been successfully completed. For layer R, we use Cellpose to segment the cell-like structures, and for layer B, we use StarDist to segment the star or particle-like structures. Each segmented image has been added to the viewer as a labels layer named segmented. So that's great, right? So I wouldn't necessarily, I'm not going to pretend that this is something, you know, you can use daily, because the vision aspect of these models is while impressive, is not, you know, at the level of, you know, someone who really understands, you know, biological images. But it's just a matter of time until they become so good that, you know, I think about it, like all these models, all this technology it's the worst that it's ever going to be, right? It's only going to get better. And there's apparently almost no limit to how good these things can become. So, you know, with enough scale, you know, there's these scaling laws that were identified early on, which kind of were mind-boggling for those that understood them initially, which basically these laws said essentially what people realize, you know, within OpenAI and some of these companies, is that you know, you just increase the scale of the models and the scale of the data, and the models become better and better and better and better, and there seems to be no saturation of that effect. So the time will tell if eventually there's saturation, perhaps because there's not enough data out there. But I personally think that there's a good chance that we don't saturate for quite some time. So these models will just get better and better. It's just a matter of scale of compute and scale of data. So, you know, I sent the paper to Nature Methods, and the reviewers came back with lots of comments. What happened is that there was a lot of unfortunately, I had provided a API key for access to ChatGPT-4, which was the model that really worked well. But unfortunately, the reviewers never got access to it. So basically, you know, it was not really working well, and I had some bugs that were introduced last minute before the reviewers had access to it. So it was a bit of it didn't go very well, or not as well as it could have gone. So I added, you know, when I finally, resubmitted, I understood, some of these issues, and I made sure that the reviewers would have access to the keys. I also realized that there were lots of things that would be required for Omega to be more practical for users. And one of them was to add a full AI-augmented code editor within Omega. And this was, it was possible to do this because of ChatGPT. Now, I think, 90% of the code of this editor is really written by ChatGPT. So I could, write code 10 times faster, or, I don't know, 20 times faster with that. So here's how it works. So you start Omega, you have these images, and you ask for a cool widget that essentially computes a FFT spectrum from an image, right? And this is, you have an image, and it's kind of a cool version because it has, padding, apodization to remove discontinuities in the border. So kind of, this kind of, tricks that you need to do to compute, Fourier spectra that are kind of very, that reflect, the content of the image, faithfully. So it does it, it makes this very nice little widget. And then that's great, but like what happens if you close the napari and you open it again? That widget is gone, and that sucks, right? So you want to be able to keep this code, right? And also, like, what if you actually want to make a change by hand because you need it? So now with Omega, you have this little, if you click on Show Omega's code editor on the main widget of Omega, you get access to a little to a small AI-augmented code editor, where you can see all the widgets and all the pieces of code that Omega ever wrote. And you can make any changes, and you can rerun them and kind of re-access them. You can also do cool little things, like, for example, here, I have lots of little kind of AI tools. Like, for example, there's a tool here that evaluates the safety of a widget. That's also the case because, as part of Omega, I also added the ability for Omega instances to send widgets across a network as kind of an airdrop for Omega. So you can, if you have a whole classroom of people with napari and Omega installed, you can, anybody can create a widget and send it to all their colleagues on the local network. Of course, it's a security issue. So here we can ask LLMs to evaluate the code that the LLMs themselves generated, or that you got from somewhere else. You could also just receive an email, copy paste it into the editor, and then you have this little micro plugin, that little widget that does something cool. So here here I asked that, I asked for an audit of this FFT spectrum thing, and it basically writes a novel about it, explaining, why it thinks that it's, it's a safe, but it's not super safe, because maybe in terms of memory, maybe it's gonna take a lot of memory. So there's I have a whole rating here. So here it's the size of the code is rated B, and it has reasons for that. And the reason why it's not A level is because it might compute, or it might perform complex calculations that could consume significant computational resources. So that's kind of cute. Right. Another thing we can do is we can modify code with AI. So we can basically, for the selected widget, we can, or a piece of code, we can say, okay, make this widget work for 3D images. Right? And you click modify. You could also just put to-dos in the code and not put anything in this box, and just click modify, and then it will just actually address all the to-dos in the code. It's another way to do it. And it took the code, changed the code to add, to make it able to work on 3D images, and it works. You can just click the little run button here on the top right corner. It adds the widget to napari, and now you can take a 3D image like this one, click compute FFT spectrum, and now you have your 3D FFT spectrum. So that's, that's kind of cool. So how much time do I have left?
A bit more than half an hour.
Okay, perfect. So now, so this was really like a a tour of all the features, and actually not all of them of Omega. And now I'm going to go deeper into how Omega works, to give you guys, insights about, the internals and how Omega is organized. So really what you see at the, what the user sees is, okay, there's a napari viewer, that's great. We have the chat window also, of course. We have the AI-augmented code editor. Another thing I didn't mention is that everything you do gets saved as a Jupyter notebook. So you can keep a record of everything, of your whole dialogue. You can turn it off, but by default it's on. So every interaction you have with Omega gets recorded as a Jupyter notebook with like screenshots for what happens, for what's happening on the napari viewer. So you can also have a trace of what was seen on the viewer. As I mentioned, you can also exchange code with other instances of this code editor, which is a companion thing to Omega. That's the visible part, right? Beneath that, you have the kind of the back end of that, which is you have a web server that serves the actual page you chat with. You have some AI tools that are part of the editor. You also have a lot of Python code preparation and repair features, and also you have ability for Omega to capture exceptions at the system level. So it's aware of all the exceptions that happen, including when you run a widget. When you run a widget and the widget fails, the exceptions are captured. And so now, if you tell Omega, oh, I tried the widget you made for me, it's not working. Omega is aware of the exception that happened, if one happened, and then it will potentially start repairing the widget and make a new one that doesn't have the issue. But at the very, very core of Omega, there's this agent. It's essentially, a way to basically give autonomy and I will dive into this a little bit. So the way the agent works is that you basically, so the base API of these frontier models of an LLM is typically just complete the text, right? So you provide some text, and the only thing it knows it can do, the base API, is just complete, predict the next token and predict the next the text that comes after, right? So how it could sound like it could sound like very, very strange and magical almost, that from just that base ability you could build such complicated things, right? But it's like many things in life and in engineering and technology, you can build, you can build things that are more than the sum of their parts, right? So the APIs provide that complete. So we have these completion APIs that just predict, the text going forward. But what we can do with this is basically the first thing you need to do is, so when you build an agent, is to first engineer the memory. So essentially, you're going to have an exchange between the machine and the user. So you need to keep a record of all these exchanges. And then really what happens is that to predict for the agent to basically decide what to say next, is essentially you have this whole history. So every time you send something you send some text to Omega, the LLM runs on the whole history every time, right? And then predicts what should be said next that makes the most sense in the context that's provided. And what happens in the case of an agent is what you actually do is also predict what is the next thing that the agent should do. And there's some sort of internal dialogues that are not visible to user that provide ability for the agent to plan the actions based on the dialogue that is memorized, but also the memory of all the things that have happened before, like what the user said, what did I say in response, which tools did I use or kind of what planning did I have to undergo that I had to go through to be able to decide on the next action and so on. So there's this loop where the user provides an input, it's memorized, then the agent decides which tool to use or not. And this is it can use multiple tools in the sequence. In the case of the vision example, it basically used 2 times the tool that allows it to see the context of the viewer, and 2 times it used tools to segment image layers. So it used 4 tools in a row, and then decided that was it. That was good. That it had achieved the goal, and then it basically answered the user. So the way that these agents, I know, so the kind of some of the first papers on that is this paper from a team at Google Research and at Princeton, and this is this idea of React agents, which is a way to make LLMs observe and reason, right? And so the way it works is you provide a task, the LLM is going to reason, it can iterate and call multiple tools. The tools affect the environment. In here, the environment of Omega is essentially the viewer, it's the machine, it's the internet also a little bit. Frankly, it could, it could write a piece of code that sends a message to someone. Right? This is possible, actually. So it actually, at this point for Omega, the environment is a whole world. Because if you can write code on a machine, you can essentially do anything. So I want to reassure people, it has never happened to me that Omega did anything dangerous on my machine. Of course, if you ask for to delete files randomly on the computer, first, it might not do it because of the safety features of these frontier models, but then, it might do what you ask it to do. So just be careful with what you ask. But anyway, so the agent will, interact with the environment, and so essentially we can provide these agents with tools that let them do things in the environment, and then they can also observe the effect of these tools and then reason on the next step to apply. So that was a little sign on React agents, which is what I'm using here. And then, I mentioned tools, but what are really these tools? So the tools are essentially a lot of ways for Omega to interact with the viewer in different ways. There's also access to the internet and access specialized tools for cell segmentation or image denoising. Also access of the Python environment. So that you can actually, so Omega can actually check the versions of libraries. It can check, the parameters of a function. It can execute an arbitrarily small piece of code that does not necessarily need to run within the napari context. It can, the early versions could install packages. I've kind of limited that because Omega was going a little bit wild, breaking people's Conda installations and environments. So I mean, now it's more like you have to explicitly ask for it and then it will do it. But in the past, it would just happily start installing packages that it thinks are needed. And that was I think now there's a check. Actually, you can actually you can double check if you have a pop-up and you decide if you want to do it or not. So here a long list of tools. So there's a widget maker tool, a viewer control tool, so a tool that lets the napari Omega control the napari viewer, a viewer query tool that is specialized for extracting information from the viewer. How many layers, what are the layers about, give me the min max intensity of a specific layer, this sort of queries. A viewer execution tool, which is more like a generic way of running code against the napari viewer, and this could be almost arbitrary kind of things. A napari file open tool, which uses the napari and all the libraries on the system to open any kind of files, either locally or online. The viewer vision tool that gives the sense of vision to Omega. Segmentation, Wikipedia access, web access, and so on. So a lot of tools that give a lot of capabilities to Omega. Of course, the way Omega is designed, it can not just run with ChatGPT and all the different GPT models out there, but it also can use other frontier models like Claude, or I've not done Gemini yet. I've not had time to engineer that in. But it supports all the open source models that Ollama supports. Frankly, at this point, except maybe for the very, very, very best ones that require very big GPUs, it's not that usable. But for the sake of hope for open source, I added it, and it was interesting and experiment. But I mean, for practically, I don't think we are there yet. But I think it's just a matter of time. Perhaps Llama 4 will eventually get there. Like, there's a good chance that Llama 4 might be the first model that eventually Omega can run on, and I really hoping that's the case. The only problem is, of course, the kind of GPUs you need access to, but you can also connect through. You can also connect through the network and have a non-local LLM for that. So yeah, that's that was a deep dive into the underlying technology. Of course, there's far more things happening under the hood. The best way to explore it is there's a bit more information in the paper in Nature Methods. There's also, of course, the code is the real repository of all that knowledge of how it works. So live demos are dangerous, and then there's something even more dangerous than a live demo. That's a live demo that's recorded. So let's live dangerously. So I'm gonna show you guys a little bit, what you can do. So let me close napari. Let's really start from the beginning. Let's open a terminal, or revisit this terminal that's open here. Let me just start this. So let me start napari here on the terminal. So for those that don't know what napari is, or don't know how to install it, I'm not gonna go through that, but there's a lot of resources on the web to do that, to learn that. So here I just open napari, and Omega is already installed. So I will just start it here on the plugins tab. I just open napari. Sorry, the Omega plugin. The Omega plugin is called, perhaps sadly, napari ChatGPT. At the time, I thought the branding would be good, because at the time there was only one LLM of that caliber that was ChatGPT. But in hindsight, that was not the smartest thing to do. But anyway, that's the case. So Omega is the agent that lives inside of the plugin called napari ChatGPT, and that's gonna be that's it. I can't really change this now. But so when you do that, when you start Omega, you have a lot of options, and you can start conversing with Omega. You can also have access to the editor, and you see I've been having a lot of fun with lots of little snippets of code that are doing lots of cool things. And then when you want to start Omega, you first thing you need to do is choose the model. Fortunately, OpenAI has a slightly odd naming convention, so they also release a lot of cool models all the time, so that's a good thing. But at the same time, it makes it difficult for me to curate the list and only maintain the list things that I know for sure are working. The newest things somehow are breaking some of the APIs that I'm using internally, and therefore what tends to happen is that this list of models, not all of them work, so you have to kind of find the ones that are actually compatible. So I will try to keep this up to date, but it's difficult to have that up to date all the time. So of course, GPT-4 is the better model. Then you can still use the old 3.5, but frankly, I don't recommend it. The plain GPT-4 models are okay, but they're not as good as the latest 4.0 models. So basically, and you want to avoid models that have fancy names like real-time preview, this and that. So I think you want the most recent GPT-4o model that doesn't have, that is just a plain date and no kind of additional specification. So I will pick this one. This is the 4o is definitely better than 4. So I will take this one, which seems to be well, not that's actually not true. This one seems more recent actually. Right. So I will probably, of course, it's always unclear which one is the month, because sometimes in the US they tend to flip things around, but I would assume this is probably the better one. And we will test that in a second. So there's a parameter which is a level of creativity. I don't recommend, I mean, it's fun to play with, but I think normal is good. And the other ones are, you know, if you really want to get slightly more creative, but also less accurate sometimes, behaviors. The code generation is itself is highly, you know, serious. And so when you generate code, you don't want to be super creative. You just want to write code that works. But when you generate ideas or plans about what code to generate, you can be more creative, right? So there's a bit of a modulation of creativity of the model depending on the particular task that it's going through, right? You can also choose the kind of memory that the model has, you know, hybrid, bounded, infinite. The personality, which is always very fun to play with. And then you have a number of features for activating, you know, auto repair codes, you know, fixing imports or not. So usually I just leave these defaults. You know, this is a good set of defaults. And there's a special tutorial mode where, you know, Omega will adopt a more hand-holding attitude and kind of tend to ask you, present options to you and then ask you which one. Like when you ask for something, it will present options and ask you what you think. So it's a little bit more interactive, even more interactive, and a little bit more hand-holding. And then, as I mentioned, you know, you can save all the code and all the interactions as Jupyter notebooks where you have the whole dialogue. This is also activated by default, and it will be saved somewhere on your desktop, you know, in a nice and clean and organized manner. So let's just start it. Let's just, you know, I should stop talking and start showing you things actually. So here's the window where we can dialogue with Omega. I'm gonna, in the interest of, you know, not, you know, in interest of making my life easier, I'm gonna take, you know, kind of some examples I have here that I have from my reproducibility analysis that's in the paper. So here in this, you know, example, which is, you know, I propose to load the astronaut image, okay, and I have this, you know, that's going to also make my life easier not to have to type all this. And then I'm going to basically ask the following. I'm going to ask to convert the selected RGB image to grayscale using human perception-based weights, then apply a light Gaussian blur of sigma 1.5 to the resulting grayscale image. Finally, create a new RGB image that visualizes the gradient of this grayscale image. The hue is proportional to the angle of the gradient vector at each pixel, and the luminance is proportional to the magnitude of the gradient. That's interesting. So let's do a little fun thing. Let's not select an image and see what happens. It seems that no valid RGB image layer is currently selected for conversion. Could you please select the appropriate RGB image layer so I can proceed with the conversion to grayscale? Sure. Done. I'm using the napari viewer control tool to tackle your request. Convert the selected RGB image astronaut to grayscale using human perception-based weights. And it gives us the weights. These are standard weights to basically, you know, project the RGB to grayscale, and they can reflect how our eyes do it. The tool completed successfully. The astronaut image has been successfully converted to grayscale and added to the new layer. The next action is I'm using the napari viewer control tool to tackle your request. Apply a Gaussian blur with sigma 1.5 to the grayscale image layer that was just created from the astronaut image. It works. And then I'm using the napari viewer control tool to tackle your request. Compute the gradient of the blurred grayscale image, create a new RGB image where the hue, blah, blah, blah. There's an error that happens here. So something happened, okay. I'm using the exception catcher tool to tackle your request. So it's kind of looking at the exceptions. I'm using the viewer control tool to tackle your request, compute the gradient magnitude, create a new RGB image. So it's kind of trying to get to the next step. And it seems it keeps making a coding mistake here. And then here it kind of stops it stops acting. Because like, it could go, if it gets stuck into a loop, it's better to stop. It's okay, let's continue. Let's continue where you stopped. So I just realized there's a little issue here that I just realized, and that's like the demo effect, of course, is for some reason the code is not being shown here. And I'm sure why the code is not showing. It should show us the code that is generating. Yeah, so something happened. Let's continue where you stopped. We have the blurred image is selected. Try again. So let's see if it manages to do it.
Maybe a stupid question while it is breathing, Loïc, and thinking. Is this would this now be an opportunity to, for example, switch to a different language model that you say, for example, okay, this is a task it cannot solve, so let's ask Claude.
Yeah, this is definitely something that I've been thinking about, is to have the ability to use specialized models for different tasks, and particularly code generation. You've got out there are some really good code generation models. The truth is that oftentimes the frontier models are so close, and that it's just a complication. But assuming that ChatGPT, some of these companies that provide these models will provide a model that, as part of their offering, more like hyper specialized models that are very, very good at code generation, then we could do something like this. So it worked out. This try again is a bit magical. So oftentimes when things get stuck, I just say try again, and it works. And so what it did is, now it took this, the gray level image that has been smoothed out. It computed the gradient of the image, in which directions, the pixel intensities change over, and then it basically encoded the direction of the gradient vector at each pixel, with the hue, with essentially a color wheel type of scheme. So that's kind of cute. So it worked. So that's essentially, what I wanted to see is this image. So we can go to another such example here.
Loïc, just wait a short second. So we have now something like 14 minutes left. We also would like to use some time for asking questions.
Yes,
and I would say, wait a second. I think we have still some minutes to show another demo, but I would like to ask the attendees, if you have a question, please type it now. Maybe Loïc shows us another short demo, and then we go into the questions. But use the time now to type your questions.
Perfect. Exactly. So let's do that. Let me see which one is a fun one here. Yeah. Do I want to go for such a complicated one? Let's try it. Let's go crazy. Okay. So I load the camera image. Okay. And then I'm probably gonna be restarting here. I'm restarting here because I want to have a clean history. That's not make our life more complicated than it needs to be. So I'm asking, please create a widget that takes a 2D image as input and splits it into k by k tiles, where k is a parameter in the range 4 to 256. Snap this parameter to the closest common divisor of both x and y dimensions. For each tile, compute the entropy. The output should be an image of the same dimensions as the input, which is obtained by upscaling the image of tile entropies, 1 pixel per tile. Using a parameterizable interpolation method, the tile size should be a parameter of the widget. Okay, so that's not an easy one. I don't think I can write this in 30 seconds. So we are asking for a widget. So there's difference between asking for widgets and asking for doing things right away. And the only problem with generating widget is that Omega has no way of knowing if the code is good, because it's not supposed to use it. It's just supposed to make a widget. It's not supposed to use the widget. So supposedly there's a widget here now doing that. I'm very curious to see if it's actually going to work. So I'm going to maybe do 8 here for the K. I'm going to do bilinear interpolation. Let's go crazy. Let's do bicubic. And the selected image is the camera image. So let's see what happens. That's it. That's the image. That's the image of entropies of this camera. So basically, this layer that I added on top of the camera image is quantifying where in the image, what parts of the image are the most complex from a statistical standpoint. Right? So these are the places where there's lots of, details and interesting things. And look, this happened in within a minute. You just need to, so you're only limited by imagination. If you can describe it, if you have the patience to ask for it to try again when it fails and argue with the thing, you can make it. And then this thing now, this little thing, is in the code editor, conveniently already selected here. That's the code that was generated. It should be displaying here, but I don't know why it's not doing it. Yeah, you can learn from it. You can do things like, with the editor, you can do things like binary reformat the code automatically. It's AI powered. Check the code safety. Improve the code comments and explanations. So if you write your own code and you need comments, you can do that. Anyway, so yeah, that's it. If you guys have questions at this point, happy to take them.
Thank you very much, Loïc. Limited by imagination. That's a nice way to start the question. Esteban, do you want to read out some questions?
Yeah. And first of all, thank you, Loïc, for the talk. It was amazing and very, very impressive. I have several questions. I think we can start with I think you mentioned this, but does this only work does the Omega work for the free versions of ChatGPT, or can you also use the more advanced versions?
So there's no free version here of ChatGPT, because it's not ChatGPT we're using. Actually, what we're using is GPT.
Okay,
it's the API. So we're not using. So there's actually a difference between ChatGPT and ChatGPT is built with GPT, with the GPT interfaces. And what you need to do is you need to have an OpenAI account, and you need to have, and you essentially need to activate the API for your account. There's the repo, the Omega repo has all the explanations on that. So if you go here, if we go to the repo, there's a wiki somewhere, and then there's explanations on how to get an OpenAI key. So this is all explained. Some of the things might have been, it also tells you what it costs. So this is probably old at this point, but we're roughly talking about $1 for 100,000 tokens, which is about 75,000 words. So it's not very expensive. So
Hmm.
back when I wrote developing Omega, which involved coding for 2 weeks straight and then using it constantly, that was $13. So it's the sum total of, I mean, the initial phase of development of Omega was like 2-3 weeks. With it was $13. So now some of the the price of the models have been going up and down because every time there's a new model, it's more expensive. But then the older ones get cheaper and so on. So this is not, ChatGPT, you either use the free version, you will pay $20 per month to have the better ones. This is separate. Still access it from the same website, but it's separate. It's API access. You need to have an API key. This is all explained here in the documentation. And then you can, and then you pay per usage. So it's not like a fee for 20. Yeah.
I think related to that, and before we go to the more philosophical questions, is someone asked, does it create multiple requests itself inside the environment, or do we have to control over how many tokens it would use?
There's no control of how many tokens are being, there's no, unfortunately, and I've been thinking about adding some feature where somehow we have a counter, like there's a counter and maybe an estimation of, how much money you're spending. You can control the spending within the OpenAI interface. You can say, oh, for this key, I want to limit my spending to $10. And after when you reach $10, the things stop working, and then you have to go back to the website and increase the. So you can control the spending. It's not like out of control. OpenAI has features for that, but that's the case for other providers like Anthropic also has similar things, right? So, and that works really well with all of that works very well with Omega. So, yeah.
And so now we go into the more, again, as I said, philosophical questions. So this is a question that has unsurprisingly come up a lot with these LLM talks. And what future do you see for bioimage analysts as a career if LLMs will be able to do this job in a few years? Asking for a friend.
So yeah, I think it's the same thing that, like last year when I started coding with the help of ChatGPT, I was like, this is crazy. I'm 10 times faster. Like I would never have been able to write ChatGPT as fast as what happened, like without the help of ChatGPT. Because I learned a lot about, ChatGPT was teaching me a lot of very advanced Python things because I needed to introspect the code, analyze the syntax tree, bunch of weird things that I had to do to maximize the chance that this would work. It's the same thing with everything else. So now with bioimage analysis, if you're bioimage analyst and you use Omega, you can start distributing little widgets to all the people that you're helping with, or if the other people are yourself, then you can start generating all these little widgets. So instead of spending half an hour writing an entropy mapping widget, and then packaging it as a plugin, which would take another 2 hours or half an hour perhaps for Robert. Then you can use Omega, get the code in less than a minute, and then move on to more complex things, right? So you can spend more of your time doing the more advanced things that we're still very good at, and interacting with people also, frankly, because that's until these things are running inside of robots, we're still kind of safe there. But in general, I think it's just a multiplier effect. So you can do more things faster. I don't know. So that I think that's it. I don't think it's a problem. Although I think you want to definitely like learn to use these tools and get good at it. Like you want to, like I think a bioimage analysis without LLMs and these sort of tools is certainly not going to be able to compete with image analysts that are writing code 10 times faster with Copilot and ChatGPT and writing widgets with Omega or whatnot. And of course it's you know, I think it's if anything, it's a plus, I think. But you have to engage with it. I think that's the key.
Yeah. And so we only have time, I think, for one more question. And you said that the model will just get better and better, but won't it be increasingly more difficult due to the increasing sparsity of novel data that's available for these models to learn from? And the person who asked the question links to a paper called AI Model Collapse when trained on recursively generated data from in Nature earlier this year.
Yeah, I don't believe in this. I think, you know, there are ways to generate new tokens. So I do think that, you know, I do think, you know, if you think about, where do tokens come from? They come from humans writing, you know, code and writing text and then recording their thought traces in text, right? But I think, you know, you can imagine, how, you know, using self-play, for example, you think about, you know, how AlphaZero could, you know, learn to play chess just from the rules of chess by playing chess with itself for millions of times, and within a half a day or something, it went from not knowing how to, just knowing the rules of chess, to barely be able to win against anybody, to actually be the best player on the planet. So I think, you know, if you give an LLM a world in which it can play with itself and explore, there's absolutely no limit of what it can learn. You just need the laws of, the rules of chess, the laws of nature, a computational substrate to play with, and then everything else is just, you know, self-play.
Yeah, I think we are exactly on time. We still have at least one other question, but maybe we can then continue this in a forum discussion in ImageSC as we did for the previous seminars.
Okay.
Okay, then let me finally thank you again, Loïc, for this fantastic presentation. And also let's thank Omega for having this discussion with you while you were presenting it live. And that's actually really, really nice. I also would like to thank again Christina, Christa, Christian. Oh, that's really challenging. And Esteban for helping behind the scenes, and the funding agencies, the Chan Zuckerberg Initiative. And the Broad Institute helping us with the Zoom so that we can make all these things happen. The next events are coming in November. Please check out our globias.org website for the next events. And yeah, last but not least, again, Loïc, thank you very much for being with us.
Thank you for inviting me today. It was great. Thank you.
Thank you. Have a good flight.
Thank you.
Have a great weekend, everyone.
Take care.